All right, so here's going to be a quick example of how to graph a function, a linear function that is. So if we look at a function like f of x is equal to 2x plus 3. By the way, you may want to have a ruler handy for this or some kind of straight edge, so you might want to pause the video and go grab one of those now. All right, so this function defines a sort of a set of inputs and outputs. And what we want to try to do is we want to try to draw a picture that shows sort of what all of those inputs and outputs are, in part so that we can get a sense for how the function is behaving. So the way we're going to do that is first we're going to create a table, and then we'll take that table and we'll plot the points from that table, and then we will graph the rest of the points based on that. We'll see what that means here in a second. So the first thing we need is we need some values from this function. We need some of the members of this function. So we're just going to pick some inputs, and we can pick whatever inputs we want. Since we can pick whatever inputs we want, I'm going to be lazy and pick very, very easy inputs. So things like 0 and 1. And maybe I'll pick 5 just to be a little bit further away from those things. 3 should be enough for now. So then the question is, well, if those are my inputs, what are my values for f of x? To be clear, these aren't all of the values in the function. They're just 3 examples that I'm pulling out of the function. So f of 0, to find that, I would let the x become 0. And I would find the output when the input is 0 would be equal to 2 times 0 plus 3, which is 3. So that means when the input's 0, the output of f is 3. Right, so I just kind of draw some lines there just to separate my work. Now we're looking at the output of 1. So when the input is 1, we've got 2 times 1 plus 3, so that would be 2 plus 3, which would be 5. So f of 1 is 5. So when the input's 1, the output's 5. One last thing to look at here then, when the input's 5, I would have 2 times 5, plus 3. 2 times 5 is 10, plus 3 is 13. So now I have 3 values, or 3 sets of inputs and outputs for this function. It's not all of them, right? Because really we could put any input we wanted to, and we could get an output for that. So there's an infinite number of things that we could have in this table. This is just 3 of them. What we're going to do, though, is we're going to draw a picture of all of the rest of them. So the way we're going to do that is with a graph in a coordinate plane. So we would draw our input axis, which we oftentimes will call our x-axis, right? And we'll draw our output axis, right? Output, blah, 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 blah. And we'll need some scale to show us what we're counting by here. So I know that my outputs need to get up to 13, so maybe I'll say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's not going to get me there. So maybe I'll count by 2s. So I'll call that 2, 4, 6, 8, 10, 12, 14. Right? These numbers down here would be the negatives, but I'm not going to worry about those too much for right now. Over here on the x's, I'm going to have 1, 2, 3, 4, 5, 6. That's plenty fine because we only really need to go to 5 to plot these values. So 1, 2, 3, 4, 5, 6. And then it's just a question of plotting this information. So we've got 0, 3. So when we input 0, I'm going to go ahead and switch colors here. When we input 0, our output is 3, which we would have right there between 2 and 4. When our input is, let me go ahead and zoom in on that so you can see a little better. When our input is 1, our output is 5. So 5 would be in between 4 and 6. And when our input is 5, our output was 13, which would be in between 14 and 12. So if we've done that right, and it's going to be a little bit approximate for us here just because we're not using graph paper, but if we've done that right, we should see that our function looks linear. And if we line this up, that's pretty darn close to linear for not using graph paper. So we said that this was these were just 3 of the values in this function f of x equals 2x plus 3. So what about the rest of them? You know, what about the input or what about the output for 2 or for 3 or for 3.5 or 3.67? Well, it turns out that all of those inputs would be along this same line. So when we input 2, for example, if we kind of try to line this up, when we input 2, our output should be about there, right? That looks like it's about 7, right? It's right there between 6 and 8. Let's just check that real quick. 2 times 2 is 4 plus 3 is 7. Just what the graph showed. And in fact, that would work for every single value along this line. So to sketch in all the rest of the values for f of x, now what you can think of this line as, you can see our graph was just a little off there. What you can think of this line is not a line, but actually just a whole bunch of points, an infinite number of points. Points like 3, 9, or 4, 11. But also weird decimal points, like 3.5, which would actually not give us something too weird. 3.5 would give us 10. So 3.510 is on here because 3.510 is also in this function. Okay. What I want you to do now is write down any questions that you might have about graphing this tomorrow. When you walk into class, I expect you to be ready to ask questions about this example. Also, on your own, I'd like you to graph g of x on a separate sheet of paper, and we're going to define g of x to be negative 3x plus 5. I want you to be ready to turn in the graph of g of x when you walk in the door.